Have you ever wanted to pose or rig skeletal mesh the quick and dirty way? Well, I've got the perfect solution for you. With one control rig that is procedurally made, we'll let you do that with characters, vehicles, and even dinosaurs, weapons, and even giant monsters like this one. Not only that, but you can also modify your already made animations. However, this does not replace proper rigging and is dependent on the bone hierarchy. So start by right clicking in the content browser, go into control rig, we'll name it CR as a prefix for control rig, procedural test. We can see that there are no hierarchies here, there are no meshes here because we haven't specified it. And we only see the forward solve here. Basically, we got the construction, the forward and backward solve. As for preview, let's put something here. Beside the mannequin, of course, I'll go with a beer because for obvious reasons. You start with the construction event. Here we still don't have hierarchy. You can click import, but we don't want that because we want it to be procedural. There is a node called import skeleton, which does this for us like this automatically. And we can see that the bones are in yellow. Normally they're in white. If you import the yellow, means they're procedurally made. And what we're going to do is that for each bone, we're going to create a control. So I'm going to go for each. We can put these items here into the array, but just for the sake of getting used to, we can get the get all and select bone. Put it into the array. And how we will create the controls, we got the node spawn control. And it's going to give us a compile error here because we haven't specified this one. For this, we're going to get the, because when you spawn, we have to give it a transform. So we gonna get the bone transform. So get transform. And plug that into the initial value just to set it up here, and then reroute it to the offset transform. And now we got a control for each of the bone, as can be seen. I don't know why do I have kind of a problem with the navigating with my mouse. You can see the other controls, like in the spine, they're inside. So we can change the shape. I personally like the circle thick, although it's not that visible now. We can adjust it later on. So for the color, I also like it to be green. It's gonna give us yellow. For some reason, there is a bug here. You have to initialize it a couple of times. Now, okay, it's good now. And you can see that the names, these are all the controls. They're also yellow because they're procedurally made, like I mentioned. The names are not correct. They're, I wouldn't say not correct, but they don't correspond to the bone. So to change that, we will get we have the name here. And to know that the bone name, to distinguish the bone name from it, I mean, we can actually do this. So let's see. So it will give us the same name as the bones. To kind of differentiate it, there is this node concat that allows us to add something or before or after, because we can distinguish from it. I'll put an underscore control as a suffix. And we got the control and at the end. We can also change it, like make it so that it happens in the beginning. So we have control, at the beginning. We can have that as well, but I personally like it to have it at the end. And by the way, that non normally for names, they're special. It's a non is a special name, means empty or zero. Just as how nil means zero in some sports. So now we got our controls, and let's try to adjust the controls. Rotate it, doesn't seem to do anything. Translate it, doesn't seem to do anything. So for it to affect the bones, we have to make that the bones get their transform from the controls, because controls are the ones that we are manipulating. For this, that's what the forward solve does. So to do that, we'll have to get the transform of the controls that we made from the bones to control the transform of the bone. So we will use the for each again and another get all, but this time we're gonna get all the controls, and we're gonna set the transform, and the item would be the bone. Now how can we, now this gives us the name of the controls, but how can we translate that to the name of the bone? Easily, by just subtracting this suffix from the control. It will give us the bone name. And to do that, the node we're going to use is replace. So this is the old one and this is the new. So it will search the name. If it has this part, it will change it to this one. Now, just to make it easier for the sake of the tutorial, I'm gonna make this a variable, and we're gonna rename it. Oops. Oh, yeah. We're gonna rename it control suffix name. Just control suffix. We'll compile it, and we got the controls right here. So the old one is this one because the control has this name, and the new one is none, which means empty. We will plug that into the name. Now I'll have to get the transform of the controls and plug it into the value here. But you can also do it like that. You can get the bones, iterate over the bones, and get the transform of the control. So we'll have to again concat the name to get the control name and get the transform of that into the bone. That's an option as well. But iterate over controls is actually better because sometimes we may not want to make controls for some bones that we don't want. And now you can see that it actually does affect the bones. However, it's still not as what we would like because it only affects one bone, and to easily rig it, we need to have it's the same hierarchy as the bones themselves. So to do that, we will have to give the parent name. And to do that, we have to parent it, the control, to the control itself. So we'll change this to control. As for the parent, we need to get the name of the parent control. So how do we do that? First, we have to get the parent. Get parent of the bone that we are looking at currently. So in this case, we're gonna get spine top, and the parent of it is spine 0.4. So we're not gonna put that into the name because we need to get the control. So we have to do this concat again to get the name. I think you should be familiar with it by now, and put that into the parent name. And you can see that it's just a pile of mashed mesh. This happens because of the space that we're working on. Just changed the transform of the bone from global space to local space, and everything should be working now. As an example of that, let's get a bone that's parented like this knee. We can see that affects all the other bones, or when we went inside the previous time, we got this bone. Now let's manipulate it. So now it works. It changes all the bones that are in hierarchy, and you can also see that from the hierarchy itself. Now it's parented to other bones. Now this is good. Let's actually save it. So now this is good. How about we change the animation? Let's put the specific animation and put the bear attack. It won't show the animation, but you can see it's played. You have to change it to backward solve for it to appear. And it may not be that obvious from the viewport. You can see that the controls stay in their place, and what we want is that the control gets back to the bones in the animation. And that's what backward solve does. Basically, it is the opposite of forward solve. Here we got the controls and set the transform of the bones from the controls. Now we want to do the opposite. We want to set the transform of the controls from the bones. So what we just did here, we have to reverse it again for each. I'll just copy this part. Actually, I'll copy the entire nodes in the forward solve and just paste it. We're gonna search for control again because easier. So what we're doing in the backward solve is that we get the controls, and we are gonna set the transform of the controls from the transform of the bones. So since we're just setting the controls and we're getting the controls, we can just plug the item into the array element into the item, because they're the same thing. And for the name, we have to remove the suffix from the control name to get the bone name. And of course, we have to also make sure that the transform node is set to bone. And now when we play the animation, we can see that the controls are actually, let me increase the size of the control. Where's the transform scale? Much better. We can see that, yeah, now it follows the transform. How does it fare for other controls? For this bear, it's good. Let's, I don't know, what should we get? Maybe this Bellica, one of the Paragon characters. And we can actually see that we don't have much control. We only have 3, 4. And you may be wondering why. And if you're wondering if it's this is in backward solve, let's change it to forward solve. You can see that it works, but we don't have much. The controls are not made. Did we make any mistake? No. The thing about it is in class setting, and I actually took about 2 hours to find this one. You have to go to limit and then changing the node run limit plus the procedural element limit. Since we know what we're doing, kind of, I'm gonna make this like 2000 and this one also like 3000. And after just changing those settings in the class setting, we can now get our full rig. But then another improvement that can be made, and this may not be visible for this one because their scales are kind of similar, but let's get something getting something smaller. This is good. Spider. You can see that for very small characters, this kind of happens. What can we do? And if it's large for this one, what about if we get like a really big character like this one? You can barely see even the controls. They're so small compared to the size. So what can we do about it? We don't have a way to get the how can I say, the bounds of the bones, unfortunately. Hope that gets added. But as a temporary solution or a workaround that I was able to reach is to get the both the parent and the bone distances, or the translation, and get the distance from it. Between this and we have to get the parent control as well. Parent transform. And we put that into the translation. Now, if you put this directly into the scale, lo behold how terrible it is. You can do that, but you have to first remap it. And the values that I'm going to do is the ones that I found to be the best for me. After many trials and errors, I've come to the conclusion that these values are the best. And not that good. Now, the reason behind it is we got this in local space, this vector of the bone, and the one we're getting the parent from is from in global space, so we have to change it to local space. And we kind of got something kind of respectable here. Now let's look at the other mesh. So yeah, this is respectable actually. This is good result. Let's get this one. Not the best result. So we should actually, yeah, the better option is to get this from in global space as well. So we put that into the translation. We also change this one to global. So you can see this is kind of better. It works on the small spider. So let's see. You just press F, by the way, to go into viewport. This seems easier to work with for me. So your mileage may vary, and this works on really large meshes as well. Look at this mesh. Look at the size of this mesh. And it works on it as well. And you can like see in here, it's large. Now for the interior controls, like I said, there is no way to get the bounds so that you can offset it, but how that gets, like I said, fixed. One thing is that the colors are not that very good, or they're not that good. Let's separate this forward and backward solve. One way to do it, one way to actually give it much more better look is to use the colorize after we make the controls. There is like a colorize controls. This is in the library. So we got the we have to first get the controls, and let's see what it does. And it doesn't seem to do anything because we're getting the bone and not the control. So in this case, we just get the controls here. You can see that it kind of gives a nice division for it. And this is one way. What this does is that it divides it in the middle. And this case, it's in the X plane. So it puts a plane in X, and basically anything to the right, it will give it this color, which is red. But yeah, right, I guess it's into the character right, and to the left of it, it's the green. And anything in the middle is yellow. So anything that that's in the middle, like these tails, they're in the for the yellow color. This is a really easy way to color it. I'll show another way to color it, but we have to first see that one kind of issue we got with this model is the way the controls are laid out in their transform. They're not that how can I say, not in the correct position, we can adjust that and changing the rotation for the control shapes. And to do that, we, since it's in quaternion, we got to get the Euler, or Euler, from Euler, yes, to quaternions. This is one, and to get the transform of it in local space, to Euler, or Euler quaternion. Yes. No, this gives us the transform, and we can do something about it. Add vector, and basically we can just put this vector here and rotate the parts that we want. So it's either in X or Y. Let's see, this seems correct. Actually, this seems correct, but it is not. Let's try with the Y, and we can see that now it seems correct now. It actually, especially on this head thing and the arms, it looks correct. So that's for this model. Let's try another model. This mechanical bull, and you see that kind of, but we got one problem here. For this one, it's not the best to put it like this, and we kind of have to put the 90 in the X, the 90-degree rotation for this model. And the culprit behind this one is if we draw a hierarchy, let's draw a hierarchy, here, and kind of change the thickness to 1. We can see, let's get a bone. This one might be a good option. This bone, its direction is minus Y. So it's in the Y axis. So it's because of the axis of the bones that are made. There is unfortunately not a way to get the axis going, or one that I don't know how to easily do that to get the axis. So I auto rotate it to the correct orientation, because it depends on the person who made it in the model. I don't know if there's a way to query that in control rig, but that's the idea behind it. So in this model, I think we just have to make it 90 here. No, we have to make it 90. Yeah. And this is because the bone is oriented this way with the x-axis to the front. As far as I know, there's no easy way to query that in control rig. If there were, it would have been much better. But yeah. By the way, we can change all of these. So and let's look at this model. Actually, let's remove the draw hierarchy. Don't want mess. We can see that for this model, everything is so large and our workflow is not wrong. But here, the culprit is the skeleton. When you look at the skeleton, especially the root, you can see that it's scaled to 100. That gives us this large shape. Let's go to the mannequin, Manny. And here we can see that it works kind of well. Because of the method we're using, we can see that the head and the necks are really small, because the distance between it and the parent are small. So they are small there. However, we got these two large things, and they are the IK controls. They don't do much in the for rigging for now, so we can actually remove those simply by just check if the name of the bone contains, let's say the name contains, it's kind of crowded here, but let's move these out. So let's make sure that the name it contains, if it contains IK, like this one, IK with an underscore, if it contains that, then it will not spawn a control for it. Oh, I forgot to connect that. So now we got rid of the IK, and the only one we got here is this one, this pelvic control. However, we got our rig working properly, some kind of. So that should be it. And another way to make it is to use structs. I made this custom struct with the array of string, name, linear color vector, and rotator. And the name array, I'm going to use it for the words of the similar words that I want to filter them out. The shape is the shape that I'm going to use for that for those that have this name. The color is the color that I'm going to colorize it. The scale, sometimes depending on the shape, you may need a different scale. Rotation is also important because they have different rotations. Make let's see, control shape. So what I'm gonna do here is get our struct, which I named control reg shape setting. Gonna compile that. We got this one. Now to set something up, kind of. Oh, I forgot to make this an array. So here, let's make one from scratch. Basically, the shape that I want. What am I gonna want to? So for this one, we got this kind. What is this? This shape? Yeah. Let's change the pelvic bone. So anything that have the pelvic name should have probably a hexagon. Hexagon thick. By the way, if you don't know the name, you just click here and just type the name, any of the names here. And the one that I'm going to go for it is the hexagon thick. So you have to type the same name here. Just you can copy it here if you select it. Depends on you. Anyways. Hexagon thick. And the color that I'm gonna set is I'm gonna make it kind of a lighter blue. Not that light, but I guess you're getting what I'm saying here. And the name that I'm gonna check for, if it have it, is let's see, what's the name? Pelvis underscore. So how can I use this? You get this and then run a for each loop for it after you spawn the control. And if we have to do another for each actually to check the name, if it have the name specified in the array, we have to set the control shape. This is shape settings, and the control that we're going to work in is this one, so the one we're getting, and the shape is this one. The color is the color that I'm going to set. The name is the shape name. The transform, we're only gonna bother with the scale and rotation. So, and the name is that we're gonna check if it contains this name. Let's get our name. Actually, it's the opposite. The name that we're gonna search is the the control name, and we're going to check if it has this name in it. You can do it the other way as well. If it's have contains, I think this is kind of better strings for these operations. So to convert this to string, put a branch and then type true. And now you can see that because of the scale of the pelvis, because we haven't put the scale in this one yet, so that scale should multiply with our scale if we want to, oops, multiply. And you can see that this is not correct for this kind of setup. So we can actually change the rotation here. Let's try 90-degree. And it's now correct. And we can do that for the other controls if they have the same name. And the reason why I made this an array of string, because if it's case sensitive, let's try another name. Control leg is a bit buggy. If we remove our first one, you can see that it returns to the original, even though the only difference is the capital P. So I've made the snippet on the Epic developer website, so you can just go to the snippets and copy all of the nodes and click the copy full snippet to copy it and paste it with Control V in an empty control rig, and it should work. That should be it. Hope you found this useful. Later.